Alright, so today what you're going to be working on is the Introduction to Physics worksheet, and so we'll be going through all those problems. So let's just take it from the top. Number 1 says, a worker is to paint the walls of a square room 8 feet high and 12 feet along each side. Alright, so 8 feet high, 12 feet along each side, so I got 8 feet, 12 feet here. Alright? What surface area in square meters must she cover? Alright, so first off, if we find the square footage of one side, then we can figure out, the total square footage she needs to cover. So simply, area is length times width. Area equals 12 times 8, which equals 96 feet squared. Okay? So now the key here is it doesn't want it in feet squared, it wants it in meters squared. So we're going to convert here. So let's convert this right away. So I start with 96. Remember, feet squared is just like writing feet times feet. So it just helps you to remember to do your conversions. So I want to get rid of feet, I put it on the bottom. The conversion factor it gives you is 1 foot is equal to 30.48 centimeters. So it cancels out one of the feet. I go again, same conversion. Centimeters, 30.48, 1 foot. Foot cancels out. I'm left with centimeters squared. I don't want centimeters squared. I gotta convert again. I want to get rid of centimeters. I put it on the bottom. I'm going to meters. 100 centimeters is equal to 1 meter. Centimeters cancel out. I gotta do one more time. Centimeters, 100. 1 meter. Centimeters cancel out. I'm left with meters times meters. Instead, in other words, meters squared. So again, quite simply, I do 96 times 30.48 times 30.48 divided by 100 divided by 100. I get 8.91 meters squared. That is the surface area of one side. So there's 4 sides of the room, so total area is equal to 4. There's 4 sides of the room times 8.91 total area. So times 4, I get 35.7 meters squared. That is the total amount of area that she needs to paint. Alright, so again, it should be relatively easy. It's just converting and just basic knowledge of area and stuff like that. So we're going to go on to the next one. Sig figs here. There should be no issues with sig figs because of my awesome lecture I gave you about the United States of America. Just real quick, United States of America, Atlantic, Pacific. Remember, absent, present, you start counting and continue to, at the first non-zero, and then once you start counting, you can't stop counting, like Pringles, and you're good to go. So here we go. 2, A is 214, A 81.60, C 7.03, D 0.03, E 0.0086, F 3236, G 8700. So there's your numbers they have. So it asks for sig figs. Point is absent. I start from the right. First non-zero. Well, they're all non-zero, so that one's easy. That's 3. Look here. Point is present. Start from the left. 1, 2, 3, 4. 4 sig figs. Point is present. Start from the left. 1, 2, 3. Good. Point is present. Start from the left. Oh, these are zeros. Non-zero. This only has 1 significant figure. All right, same thing. P is present. Start from the left. All zeros. 1, 2. 2 sig figs. Absent. Start from the right. They're all numbers, so that's 4 sig figs. Absent. Start from the right. Up. 2 zeros. 8, 7. That's 2. All right. So remember, absent. Start from the right. Present. Start from the left, and go from there. Should be relatively easy. All right. Moving on. Number 3. talks about scientific notation. So all we're going to do is put these numbers in scientific notation. I'm going to copy them down real quick. A, 21.8. B, 0.0068. C, 328.65. D, 0.219. I forgot E, so there's F, 2837465. G, 0.00038847. So remember, scientific notation, you want to get a number between 1 and 10. So I look here, the number between 1 and 10 is going to be 2.18. So I'm going to have 2.18. To get to there, I moved it 1 to the left. So it's times 10 to the, you got to make 2.18 bigger. So you're going to times 10 to the first, and it's going to be positive. Here, the number between 1 and 10 is going to be 6.8. So I do 6.8 times 10 to the, well, I moved it 1, 2, 3. You need 6.8 to be smaller to get to this, so it's -3. All right, here, I need to move it to here to get 3.28 times 10 to the, well, I moved it twice. My number here is going to be 2.19. To move it, 2.19 needs to become smaller to be 0.219, so I do times 10 to the -1, first power. Decimal point is here, so I got to move it 1, 2, 3, 4, 5, 6. So I got 2.83 times 10 to the 6. Decimal points here, I got 1, 2, 3, 4. 3.84 times 10 to the, and it's going that way, so it's -1, 2, 3, 4. Should be easy. Good. All right, it's number 3. Number 4 is a conversion one. It asks, an ore loader moves 1,200 tons per hour from a mine to the surface. Convert this rate using pounds per second, using 1 ton is equal to 2,000 pounds. So I have 1,200 tons per hour. I need to convert that to pounds per second. Yeah. So I'm going to do both. I'm going to convert the mass and the time. So let's do the time first. If I want to get rid of hours, I put it opposite. I have hours up here. Seconds, 1 hour is 3,600 seconds. Hours cancel out. I want to get rid of tons, I put it opposite. Tons is down here, pounds is up here. They give you the conversion factor. The conversion factor is 2,000 pounds, 1 ton. Tons cancel out. I'm left with pounds per second is exactly what I want. So I go to my calculator here, and I go 1,200 divided by 3,600 times 2,000. I get 666.7 pounds per second. Okay? Now, next one. It says a fathom is a method for measuring length, usually reserved for measuring the depth of water. A fathom is approximately 6 feet in length, and so we're going to take the distance to the moon to be 250,000 miles. Use the approximation above to find the distance in fathoms. So we have 250,000 miles. Number is just 5. 250,000 miles. We want to get to feet because the conversion factor we have is 6 feet equal 1 fathom. So if we can get the feet, we can get the fathoms. All right, so we're going to get rid of miles here, so we know that 1 mile is equal to 5,294 feet. Let me double check that. 5,280 feet, sorry. 280 feet. All right, miles cancel out. I want to get rid of feet to go to fathoms. So feet cancel, go to here, fathoms. On top, 6 feet is 1 fathom. I'm left with fathoms, so I go ahead and do the calculations here. I go 250,000 times 5,280 divided by 6. And I get 220 million fathoms. All right. Good. So next one's another conversion. Speed of light, 6. Speed of light is 3 times 10 to the 8 meters per second. I want to go to miles per hour. So let's do the time first. I get rid of seconds by putting it opposite. Hours up top. 3,600 seconds equal 1 hour. I cancel out. I want to get rid of meters. All right, but I'm going to an English conversion. So from number 1, they give you 1 foot is equal to 30.48 centimeters. So I can get to centimeters, I can get to feet, and then I can get to miles. So meters go down here. I want to go to centimeters. I know that there's 100 centimeters in 1 meter. I want to get to the English, so I'm going to feet. I want to get rid of centimeters. 1 foot is equal to 30.48 centimeters. Centimeters cancel out. I want to go to miles. So I go feet, miles. 1 mile, 5,280 feet. Feet cancel out. I'm with miles per hour. Exactly what I want. So again, anything on top I multiply, anything on the bottom I divide. 3 second EE to the 8th times 3600 times 100 divided by 30.48 divided by 5,280. I get it. Well, that's supposed to be 8 miles per hour. Okay? Good. So, next one's another conversion. 7. All right. How many seconds are 1 day? So we start with 1 day. We want to get rid of days. Days go here. 1 day is 24 hours. We want to get rid of hours. Goes here. We can go to seconds. 3,600 seconds equal 1 hour. Hours cancel out. I'm left with seconds. So I start with 1 times 24 times 3,600. And I get 86,400. So that's how many seconds are in 1 day. Now it wants to know how many seconds are in 1 year. So I start with 1 year. All right, get rid of years, put it on the bottom. 1 year equals 365 days. And since I know that's how many seconds in a day, I can just go right to it. I get rid of days. 1 day cancels out, equal 86,400 seconds. Days cancel out. I'm left with that. Seconds is exactly what I want. So I go here. I go 1 times 365 times 86,400. I get seconds. 31,536,000 seconds. All right. Next one is a trig problem. Okay, it's disguised by a word problem here. So you got to kind of build a picture. You got to kind of build a picture here so that you can take it to a trig problem. So it says a high fountain of water is located at the center of a circular pool. Not wishing to get his feet wet, a student walks around the pool and measures its circumference to be 15 meters. Next, the student stands at the edge of the pool and uses a protractor to gauge the angle of elevation of the top of the fountain to be 55 degrees. How high is the fountain? All right, so we got a fountain here. Water coming out. Nice. All right, so the circumference is 15 meters. So all around here is 15 meters. The kid uses a protractor to gauge that this angle it makes with the ground is 55 degrees. Well, what do you see there? Right triangle. If we can find this side, we know the height of that water fountain. Okay? So again, when you're doing trig problems, the first thing you want to do is decide what angle you're going to use or decide what angle you're going to solve for. In this case, we don't need to solve for an angle, so we're going to decide which angle we're going to use. I'll use this angle since we know it, 55. So I have to label the triangle relative to that angle. Well, relative to that angle, we call this side adjacent. Relative to that angle, this side we call opposite. All right? So next, we have to do something here. We don't have enough information. We only have one variable. We need two. Well, if you notice, if this fountain is at the center of the circle, this side here would be equal to its radius. They don't give us radius, but they give us circumference, so we can find radius from there. Circumference equals 2 pi r. So I plug in. The circumference of the circle is 15, 2 pi, and I'm looking for r. So I divide by 2 pi. R is equal to. Pi 2.38. 2.38 meters. So that is this side here. Now I know adjacent, I want to find opposite. So now you got to select your trig function. Opposite and adjacent is TOA, so that means tangent. Tangent of theta equals opposite over adjacent. Tangent of 55 degrees equals opposite over adjacent, which is 2.38. Multiply by 2.38, cancels out. I'm left with opposite is equal to 2.38 times the tangent of 55. The opposite side is equal to tangent 55 times 2.38. 3.39. Which is that side, which is the height of the water fountain. All right? So you can see this was a trig problem, but it wasn't straightforward. It wasn't just a, okay, here's a triangle, solve. You had to know to piece this together and then use trig to solve it. Okay? So last one here. We want to find the number of kilometers in 1 mile. So we're going to start with 1 mile here. We want to get rid of mile, but we got to go to kilometers. It says use 1 inch equals 2.54 centimeters. Well, I'm going to use the first one. It says 1 foot equals 30.48. It's going to save me a couple steps. So I know that 1 foot is equal to 30.48 centimeters. So the first thing I want to do is get to feet, so I can go over to centimeters and then go to kilometers. All right, so miles, I want to get rid of it. I'm going to feet, 5,280 feet, 1 mile. Mile cancels out. I want to get rid of feet and go to meter, or what is it? Centimeters. Yeah, centimeters. So get rid of feet. You put feet here. Centimeters up here. 1 foot is 30.48 centimeters. Feet go away. I go again. I want to go to meters. 100 centimeters. 1 meter. Left. No, I want to go to kilometers. Sorry. 1 meter. Get rid of meters. 1,000 meter. 1 kilometer. Meters cancel out. Okay, I'm left with kilometers, so I'm good to go. So now all I'm going to do is do the math here. 1 times 5,280 times 30.48 times 100. I'm sorry, divided by 100. Sorry, divided by 100, divided by 1,000. You have 1.6 kilometers. There you go. That's it.